I'm Maude. I'm a senior staff engineer at Slack. I have been there for 7 years as of 2 weeks from now, which, yeah, makes me a little bit of a dinosaur. How many of you in here were using Slack 7 years ago? OK, a good number. And how many of you are using Slack now? Sweet. OK. That's what I love to see. And hopefully, I had a part to play in that. I don't know. Sometimes I wonder how much of these load testing and scaling efforts have really played a role there. But in 7 years, a lot has changed at Slack, as you can imagine. So we've grown our engineering team about tenfold. Something like 90% of current Slack was hired after me. And the complexity of the product has completely exploded. And in that time, we've gone from having our customers essentially like load test in production for us to having an automated system that continuously puts a lot of pressure on our production systems every day. And I'm here to tell you the story of how we went through that whole transition. So once upon a time, we had a big customer. And for the purposes of this talk, we'll call them Big Corp. How many of you have had big customers that you've had to pay special attention to? All right. Well, in this case, Big Corp was already pushing the boundaries of our system, and both of us were very nervous to opt them into new features. At the time, deployments at Slack were a little bit of a press a button, and the code goes live to all servers within 30 seconds. It was a little bit scary. It was a little bit of the Wild West. This may or may not be an actual picture of servers fulfilling Big Corp requests. But Big Corp really liked Slack, which is great. That's what we want, right? We want them to really love Slack and talk to other customers that they have that are also big companies, and everyone signs on to Slack, and everyone uses Slack, and we all make a lot of money, and it's wonderful. They wanted to use Slack more. That's great. We want that. We definitely want that. So we needed to load test, right? But unfortunately, we didn't really have any tooling to do that. And we were still pretty small and scrappy at the time. We didn't have all these like big company resources that like the Microsofts and the Googles have, where they can just reorg on a whim and kill a bunch of projects and decide to reallocate a bunch of people to load testing. And great, cool, we have infinite money. This is fine. We did not have infinite money. But we knew that there would be more Big Corps, and we hoped there would be more Big Corps, and Big Corps business was important. So we set out to build a simple, very simple, pragmatic load testing tool. And it was indeed very simple. It blasted API requests to our servers. That is really, truly all it did. Think of a for loop, and it just iterated through a literal file of requests and just did a bunch of curls, and it was fine. There was like some concurrency that you could throw in, and you could specify a rate and all that stuff. So it was a little fancier than just a for loop, but like pretty much imagine a for loop. And for better or for worse, it actually kind of worked in that it surfaced a bunch of bottlenecks that we really needed to fix before we rolled out more features to Big Corp. And so we did that, and Big Corp was happy, and that was good. Unfortunately, it didn't test a very critical component of our infrastructure, which is the WebSocket stack. So how many of you have worked with WebSockets? Great, a really good number of you. That is not testable using just curl requests that you're making in a for loop to hit a certain set of servers in our system. So to illustrate what I mean by it did not test our WebSocket stack, I'm going to give you a very quick high-level overview of Slack's architecture. This is almost exactly what we teach in onboarding on day 2 or 3. I don't know. I haven't been onboarded in 7 years. I teach this class. I think it must be on day 5, because I usually teach it on Fridays. That sounds right. OK. So here's a very high-level diagram of Slack's architecture. On the far left, we have all of our clients. So that's like desktop users, iOS app, Android app, et cetera. And these clients send and receive information from Slack systems via these 3 distinct gray boxes, these 3 distinct APIs. So the web API, which is the one at the very bottom, if you've ever developed a Slack app, you've probably used this API. This queries all of our main backend systems responsible for the vast majority of our business logic. And then you have the Edge API, which is that middle box over here. And it queries our Edge cache, which is deployed across various points of presence throughout the world. So a standard use case for using the Edge API is when you use the quick switcher, so Command-K or Command-T if you're in the desktop app and you're looking for the channels that you're in and it fills in those results for you. That is all done using the Edge API. That's all cached in these various points of presence across the world. And then finally, there's the RTM API. So that's the real-time messaging API. That is that long-lived JSON WebSocket connection. All right, are we all still with me? Fabulous. So this red outline box is the surface area that API Blaster tested. You can see that it misses some kind of key components. And we issued all these barrages of requests against these test environments that we'd spun up, but without any actual clients to receive the data on the other end. And to give an example of why this is a very, very incomplete view of what happens at Slack, we're going to follow an example of how a message is sent. So I show up in the morning. I type good morning into the general channel. Hopefully it is not a very big channel in this case. That would be rather disruptive. And that issues a chat post message request to our backend systems. And that message is going to be saved in the database. It's going to be propagated back up to our real-time services. And I was hoping I could see my cursor, but you can trust me that I'm pointing to the teal box, the real-time services. And that's the teal box again. Those maintain all active WebSocket connections with all Slack users across the world. And it organizes those connections by channels. So let's say we're both connected to the general channel. When I send that good morning message, these systems are the ones that ensure that the message is properly delivered to all those active clients. So you have that connection, I have that connection to that same exact server. We are getting those messages over the WebSocket connection. And that is propagated right back. So let's say that we're load testing chat post message to the general channel with API Blaster. There are no connected clients to listen for incoming messages. That means that that entire outline section here is just not being exercised at all in any of our load tests. We can't witness the impact of propagating those messages, what that will have on the real-time services. We have no idea. And most importantly, we actually don't know what the impact is going to be on our clients. And that's where all of you are, right? That's what you are experiencing. It's really important for us to know what that looks like for all of you. And we were like fine with this trade-off for a while. API Blaster gave us like a certain amount of peace of mind about how like a good portion of the stuff worked, right? At least we could test ingest into the real-time services, not output, whatever, like that's okay. And that was fine, that was fine, until even bigger corp came along, which like, it's great, right? Like, with big corp, even bigger corp, also really like Slack, which is great. We love it when people like Slack, use the product. But you know, sometimes it's also a little bit of a headache. And they wanted a channel to house about 300,000 of their users, which is a lot. And about 100,000 of them would likely be active at the same time. And why was this scary? Well, we're going to go back to our example, and we're going to talk through it from the perspective of how Slack is susceptible to load-related performance problems in 3 key ways. There are more, but for today, we're just going to talk about these 3. So let's say we have 100,000 active users in that general channel. So a single good morning message would be fanned out to all 100,000 of those clients at once, at the same time. This, as you can imagine, as the vast majority of you seem to be Slack users, is not an atypical Slack use case. Pretty standard. You send a message, you really want other people who are connected to get it at the time that you have sent it. But at this size, it really was an atypical use case. So in early 2019, which is when even bigger corp was talking about doing this, these conversations, they were having conversations, about these 100,000 users. At the time, our biggest channel was maybe just under 90,000 users, and maybe 50% of them were active at the same time. So it turns out there's like a big difference between 45,000 and 100,000. Sometimes there isn't, but in this case, there really was. And that was massive fan out. Number 2, event floods. So not only did this customer have very big channels, they had very chatty channels, very busy channels. So say you're in a handful of big, busy channels. Think like thousands of users, dozens of messages coming in every minute, a bunch of reactions flooding in, that sort of thing. Every second, your client is processing hundreds of different events coming through. It can be really, really busy. And if you work at a very big company and you have a very, very busy Slack instance, I recommend actually just like either opening up Slack in the browser or open it up in your desktop app, open up the developer tools, look at the WebSocket connection and see how much stuff is going on. Like there's a significant amount of things. And even bigger corps administrators, so those are the folks who make a bunch of channels and archive channels for you and do all of the fancy administrative stuff so that you don't have to do it. It's really important at big companies, trust me. They had particularly laggy clients because these folks were in a ton of channels, in a ton of really busy channels, especially the ones where folks are writing in saying like, my Slack doesn't work, what do I do? And they're the ones making sure that everyone has attention and is getting their Slack figured out. Usually that doesn't happen though. Slack works perfectly all the time, every day. So their clients were in a particular amount of pain, and so they were in a particular amount of pain, so they were particularly worried about this type of problem. They needed us to make sure that if we doubled the number of active users, their clients wouldn't just stop. That'd be great. Unfortunately, API Blaster could test none of this at all. And then finally, we were concerned with thundering herds. So this is a fun one. So say I am company CEO. I'm a very fun company CEO. And I say in the big company organization-wide channel, the general channel, I announce, great quarter, everyone. Let's all take Friday off. So everyone who's connected in that moment gets that message. So I don't know about you, but if I get a message about taking Friday off, I'm going to immediately read that message, and I'm going to add a bunch of reactions to it, because I'm very excited about taking Friday off. And so every one of those reactions gets looped right back through. And if just 10 people send one reaction, that's going to turn into 10 reactions being propagated to 100,000 clients. So you do the math with me. That is 1 million WebSocket events. And realistically, there's no way that only 10 reactions are going to land on that message. So imagine how all of that can just really balloon. It's a fun time. Yay. So we built Puppet Show, and this was mid-2019. And Puppet Show was pretty simple, slightly more complicated than API Blaster, because it needed to actually establish a WebSocket connection. But the tool essentially just simulated actual real desktop users by spinning up thousands of headless Chrome browsers across a Kubernetes cluster. And they all logged into Slack.com as distinct users with distinct tokens. And we had them execute different JavaScript scripts to simulate different behaviors, like switching to a channel, sending a message, switching to a channel, adding a reaction, trolling Slackbot, whatever. And so in this instance, for example, we could spin up 10,000 headless Chrome instances and tell all of them via a simple script to send a message in the general channel, see what would happen. And Puppet Show worked like this. And so there was a main puppeteer in charge of the whole show, and there were a bunch of puppets. And the puppeteer oversaw all the puppets, with puppets periodically checking in with the puppeteer to update it about their state. So like, hey, I'm DMing Oscar. Should I be doing anything else? Should I keep doing this? What's going on? And then when a new script was uploaded to the puppeteer, the next time the puppets checked in, they'd receive the script and start executing it. Cool, great. Some pros. High fidelity. You can truly not get higher fidelity then literally logging into the Slack client and executing actions that way. And very flexible scripting. Turns out you can easily execute a very simple JavaScript script from a headless Chrome instance. It's very, very convenient. You can make it do basically anything. Cons, it costs a lot of money. It cost a lot of money. And by a lot of money, I mean it was costing, on average, for each Puppet instance, so each fake client, 37 cents per day to run. Yeah. So if you need to run 100,000 of those to get your test, just to test like that one scenario that you wanted to test for that customer, that's a good time. I don't know who has that kind of money to burn, but if you do, I'd love to work with you. That sounds like a really great time. And then the other problem was, I don't know how many of you have tried to spin up headless Chrome instances. Like a lot of them, thumbs down. Maybe 2 thumbs down. It took us several days to spin up over 100,000 instances, and once spun up, each pod would maybe crash partway through, and the amount of money that we had to throw at AWS to like get these pods to even like handle a couple hundred headless Chrome instances in a given server was terrible. It was a lot of power. How many of you operate with like 200 Chrome tabs open on a daily basis? Like, let's be honest. Yeah, okay. Your computer is probably not very happy sometimes. So take that, run Slack on top of it, run VS Code on top of it, and you're in for an even better time, right? Yeah, okay, so this is why my husband only logs into Slack on his Chrome browser rather than use the Electron app, because he says, why would I run multiple V8 instances if I don't have to? It was a bad time. So we managed to eventually run through the test cases that we wanted to and verify that for the customer, but once we were able to do that, we closed shop. We said, that is way too much money, it's way too much of a headache. If we need this at one point later on, okay, we have it in our back pocket, we can spin it back up, but this is in no way a sustainable tool. Cool, great. About a year later, just a few weeks into the global pandemic, we signed with an even bigger customer. Yay. And we'll call them Biggest Corp for the purposes of this talk, and they wanted to support 500,000 users in the same Slack instance. Which we were really pumped about. This was like the biggest deal we'd ever signed. It was a really, really big deal. And they had worked with some salespeople and some customer success people, and they had a completely reasonable 18-month rollout plan. We were like, cool, great. We have time to scale. We have time to test. We have time to do all the things we need to do, dot our I's, cross our T's. And but Puppet Show was not going to cut it. Like, even if we could wrangle 500,000 headless Chrome instances, we'd be looking at like over $200,000 a day in load testing costs. Like, that's absurd. Like, let's not do that. And then about like 3 weeks after we signed the deal, they came back to us and they said, so like this COVID thing, seems like it's going to last a while. And we'd really want everyone on Slack like sooner rather than later. So could you maybe ship in 10 weeks? And I was in this meeting with my manager, and we were both we were on Zoom, and we were both trying to keep a very straight poker face, right? And we were DMing each other, and I was like, did I hear that? This was like May 2020. And I DM'd her, and I was like, is August 4th, 2020, right? Is that what they said? Not, it'd be great if it was 2021. She's like, no, I think it's 2020. And I was like, oh no. So that was fun. So we designed and built Koi Pond. And we were already planning to build this. We'd actually just spun up a team specifically focused on building this, because we had figured, you know, there was Big Corp, there was even bigger Corp, there was probably going to be Biggest Corp. So we had to plan ahead. We planned ahead, just like not quite enough ahead. And the team had existed for all of like 3 weeks at this point when they came and told us that we needed to do this. So that was fun. So we pulled a bunch of people, other resources from across the engineering organization. Some people came on in a temporary fashion onto the team just to get us through these 10 weeks. So we already had the plan, and the plan was take Puppet Show, essentially, and replace the headless Chrome browsers with these lightweight client simulators written in Go. Here's how that sort of fits in with how Puppet Show was architected previously. So instead of a puppeteer, we now have a keeper. He keeps the koi. It's nice. And then we have schools of koi. Naming's great. And we run about 5,000 koi on a given school. So a koi is that fake Slack client. It's a Slack client simulation. It's a single Go routine. It is run as part of a school, which is a single Go program, and that runs on a single pod in Kubernetes. And then the keeper manages all the schools and keeps track of the overall load test state and parameters. All right. So the only wrinkle, which wasn't that big, is that we had to teach these simulators how to be Slack, which, how to log into Slack and how to establish a WebSocket connection and how to post funny memes and make requests to all of the APIs of all those various kinds and pretend to be just a regular person working at work. Simple, because the Slack is not a complicated product in any significant way. So here's how we do that. So when you boot up a load test, you need to provide a configuration file. And the file is just one big JSON blob, and it tells it what to do once they've booted, so done the client.boot, if you're familiar with the Slack API, and established that WebSocket connection. So essentially, it just looks like a big mapping of actions. So chat post message is an action, 2 probabilities, followed by a set of implementations that's down here that a koi should perform with those each actions. So every tick, which is configurable, but by default is set to 1 second, every koi iterates over all of the behaviors, so that's that top block, and probabilistically runs them based on their odds. I just said a bunch of words. What does that mean? So this is a really, really simplified configuration file where we just have that one action called chat post message. And this means that every second, every koi independently has a 4.3% chance of performing the chat.postMessage action. So if we have 100 active koi, we'd expect about 4 of them to send a message every second. That's roughly what that translates to. And I did not show the implementation of the actual steps and how we tell it to do these things because complicated. We can talk about it after if you would like to. So if you happen to be logged into a workspace where the koi were doing stuff, it almost looked like a normal workday because we had all these different actions that they were running at a different probabilistic frequency. All right, this is outdated, actually, as of a couple weeks ago. But this is the actual length of our configuration file. So when I say that it is a terribly long JSON blob, it is indeed a very terribly long JSON blob. And for simplicity, again, I'm not going to go into the actual implementations for what each of these actions looks like. They're a bit esoteric. They rely on Go templates. We're migrating them to use this fun JavaScript thing now, so that's been really exciting. So it's actually much more approachable for engineers across the company to use this type of scripting to implement their behaviors. But it was, at the time, it was the simplest solution given our really, really, really 10-week condensed timeline. So it's big, and you have to manually craft each implementation, but it's not so bad. And if you were following, plus or minus the whole intermission there, you might have noticed that with behaviors, we are able to simulate the first 2 ways that I talked about that Slack is vulnerable to performance-related load problems. So that was the massive fan-out. We can simulate users sending messages in big channels, pretty standard. And we can simulate lots of activity across a workspace. Ramp up those frequencies, and you get a lot of koi doing a lot of stuff. But what we can't simulate with just behaviors is this idea of thundering herds, because we can't generate coordinated behavior. And so that's where we have formations. So because we want to simulate real users doing real-ish stuff, we want to be able to specify the percentage of users that'll participate over that period of time. So that's this percent number here. So here we're saying 1% of koi should participate in this coordinated behavior. So take that example from earlier, the big boss sending that message about taking Friday off. Not everyone is going to navigate to that message right away once they receive it and read it. Not everyone is going to react to it. But for those that do, they won't be doing it immediately, right? There's some amount of human behavior, there's some amount of jitter in there. So we'll probably see a flutter of activity over a few minutes, and that's exactly what we want to be able to specify with formations. So barring any other projector-related problems, I don't know that I trust this. All right, if things go south, there's folks on the other side. So, all right. So, let's make this full screen. All right, this is koi pond. This is a little bit awkward with the microphone. OK, this is koi pond. It's telling us that we have a 500K continuous koi test. That's the test that's running now currently 24/7 across all of our systems in production, running currently. Because I couldn't trust the Wi-Fi earlier, already opened up the page for it here. So it's running. Our teammate Glenn fired it off about an hour ago because it had been booted down for other tests. There's a bunch of stuff in here. But what we're going to do is we are going to simulate that exact scenario that I talked about taking Friday off. So I'm going to navigate to this. Oh, and just to prove to you, I mean, this doesn't really prove anything. But there are currently, I can't see that, almost 500,000 koi running currently on this load testing team. All right, so I'm going to go to this channel. I'm going to type, "What's up, strange loop?" And I'm going to go back to my load test. I'm going to click run. And within a couple minutes, the koi should pick up that formation and start reacting to that message. Fingers crossed. All right, this is for us. We create new load test channels with every load test that we run so that we can gather data and alerts and send all that stuff directly to those channels so that folks who are load testing can have all that information readily available. And it's nice. Slack is the searchable log of all conversation and knowledge, which includes load tests. I'm going to, by default, pipe it to our load testing channel that works for this, and we're going to sit here and watch the reactions come in, hopefully. The Wi-Fi was being weird earlier, so I'm going to go back, make sure that that didn't actually run. Oh, yeah, I think the Wi-Fi is acting up. Boo-doo-doo-doo-doo-doo. I'm a terrible singer. I'm sorry, I should stop singing. Is the Wi-Fi? It is indeed terrible. All right, let me just toggle the Wi-Fi over here. Doo-doo-doo-doo. All right, come back here, refresh. Do-do-do-do. I have no more puns.
Do the individual
all right.
simulated agents, are they distinguished one from another, or does random identifiers?
They're essentially real users, so they're using tokens, so they're acting as real users. All right, so just give that one more try, and if that doesn't work, then I have a video. I'm prepared. All right, well, it works this morning. Don't they all say that? So instead, I have a video. This is from a couple months ago. We've since cleaned up the UI a little bit. None of us are really front-end engineers, so this is what happens when back-end engineers write tooling that has front-end. So I'm going to upload that script, and we are going to watch the reactions flutter in. Pick the right one. each of those, so here I'm showing the actual configuration file, yeah. So each of those are individual configurations. They get uploaded on top of the existing, so there's a top-level config that has all these behaviors, and then you can add on, and so that's what this upload is doing, is it's tacking on an additional formation. So any given test at any given point can have like 10 different formations, and you can choose between the ones that you want to run. Okay, there we go. Woo! So you may be wondering, were we successful in testing all the things that we wanted to test in 10 weeks before this looming deadline? And in short, we were. Yay, money! So we ran dozens of load tests with up to 500,000 simulated users in the weeks leading up to their launch. It was a massive coordinated effort with someone from nearly every single engineering team involved. Not only that, but we did not spend absurd amounts of money. It was costing us, remember, 37 cents a day to run per puppet per day. And it cost us 0.1 cents per day to run a koi. So that is a lot cheaper. Like 400 times cheaper. It's like ridiculously cheaper. So this is a very condensed, not to scale timeline of some of the stuff that we did. And to bring us more to today, since January 1st, we've actually run 77 koi pond tests in production. That's about an average of 2 a week, and we don't even blink an eye anymore. And a lot of these are testing all the features that you love and use every day in Slack. So with that, I will leave you all to enjoy another talk or come and ask questions. You can find me most places on the internet as QC Maude. I wrote a book at some point in my life a couple years ago. It's there in case you're interested. But yeah, that's it. Thank you so much.